So I'm going to talk about something called a Python web installer. Just a bit about myself. I'm Marc Lemburg. I'm one of the Python core developers, PSF member and board member. Work for the EuroPython Society. I have a company called eGenix. We do Python projects and we also do Python products. And this web installer is basically used for our products now. So I'm going to talk about how we came up with it. So this is the agenda. Let's start. So, good question. Why yet another install implementation? I mean, we already have quite a few install implementations out there, like pip or setup.py or easy-install or zc.buildout and a few others. We needed something that was a little different than all these. We needed something that actually made it very, very easy for people to install stuff. We needed to, because we were doing commercial products, we needed something to do binary packaging without actually shipping the source code, and that was a bit of a challenge for us. More recently, there are some other issues as well, like there's a lot of lock-in going on the Python package index right now, so people are expected to upload everything to Python package index or to install it from there, which is something that we didn't really like because we also have some other packages to ship, like crypto packages, and the Python package index is hosted in the US mostly, so we then fall under the US crypto laws and stuff, so we didn't really like that. Right, we want to distribute binary packages, and that's what we intended to do. And so we needed something that does not only work with source code packages. So if you look at the existing packages, the existing tools that we have setup tools, we have easy-install. They work very well for pure Python code. They work with packages that have C source code and then compile it on the installation platform, provided there's a compiler there on that platform. On Linux, that's usually the case, or it can be easily fixed. On Windows, it's a big problem because people usually don't have the compilers installed, and even if they do have the compilers installed, getting everything to work on Windows in terms of compilation is really difficult. And the story goes on. If you have binary packages to ship on Windows, that kind of works. There are eggs, there are wheels, they work on Windows. If you go to Linux, the situation is already a bit less ideal. For example, wheel support does not exist yet for Linux. The eggs do work in most cases, but it doesn't always work. And then for other platforms that we support, like FreeBSD, for example, like Solaris or Mac OS X, the support is either not there yet or it's very, very limited. Right, something that has been going on in the last few months a lot, there was a lot of talk about pip and securing downloads, so making sure that everything is hosted on HTTPS, that certificates checks are being done, that the packages being downloaded from the Python package index are actually being checked with a checksum, whether they are valid packages that you download from Python package index. A few years ago, none of this was really done. So basically, if you used easy-install, for example, for a very long time, it didn't really use HTTPS at all. So you downloaded everything using HTTP. It did not do any checks of the packages, not any checksum checks. So you basically installed something from a source that was not really reliable, and you didn't really know that the stuff that you installed on your machine was actually coming from the right source. So this is something that it changed now, or it is still changing. There is a lot of effort being put into it to make it work better, but it's not, well, it doesn't work for all Python versions, for example. It doesn't work for because some of the Python versions don't do the certificate checks. That's being fixed now for 2.7. It's already fixed in 3.3, I think, and 3.4. But we need it for other versions as well, so we wanted a way to make it possible to add that kind of tool chain to our system. We also wanted to make it very easy to use, so we wanted to not have the people, not have our users think about which kind of binary to download in order to make it work on their system. So the software running on their system should basically identify the platform and then make the right choice and find the right URL to download to then put it on the system. Right, so what could we do? Well, one way to do this is, of course, you just wait for the developers to do all the work for you. We waited a bit for pip to kind of get this thing running, but there is a strong resistance from the pip developers to do anything that's not open source. And so that was kind of moot to do. And it's fine. I mean, they're spending their time on their stuff, so it's okay that they don't basically do the work for us. And then we tried to identify some way of basically reusing most of the stuff that's already there. So we wanted to reuse the great code that's being written for pip. We wanted to reuse all the code that was written for setup tools and just hook in there as much as possible. So what we found is the least common denominator of all these tools is the Python setup.py install command. So that's supported by all of them. So if your installer supports this kind of interface, then you can actually make use of all these installers, and you don't have to rewrite everything. And the other important part was that they all support the source package format for downloading things. So if one of these installers finds a source package, it knows what to do. It knows that it has to run this Python setup.py install to get it installed. And so we use those two things to write the web installer. Now, in order to make it work, we just had to make the web installer packages look like Python source packages, even though they didn't really contain just source code. And we had to implement this interface. And then that automatically got us all the support from the installers for doing other things, like, for example, managing the installations, doing the management of the installation database, doing dependency checks, doing all the metadata handling, implementing all the PEPs, and all the rest that you have to do for managing things on the platform. So let's do a requirements check. With this design, we could automate the package download selection because there was code running on the installation platform. We could add checks for certificates, for example, or for the checksums on the platform, so we could make sure that everything's authentic. And we could add extra functionality. For us, for example, it was, we haven't implemented that just yet, but we're going to do that. For example, we wanted to generate evaluation licenses for the software automatically, so that people don't have to go to the website to do that. Right, implementation design. Well, like I said, we needed to put a minimal source package on PyPy. That source package would only contain the very basic things. Most importantly, of course, the setup.py and the web installer code itself. Plus some additional information. I'm going to get to that in the next few slides. One thing that the web installer needs to know is whether it's actually running as web installer or whether you're currently building a package. Because when you build a package, you use the setup.py as well, and you don't want the web installer to just start downloading stuff for you. Instead, you just wanted to sit there and do nothing. Whereas, if the web installer is running on the installation platform, you need to know that it doesn't have everything yet, so it needs to download something. So the way that we did it is we used landmarks for that to identify whether to run in web installer mode or whether to run in build mode. So basically you just pass a list of files or directories that need to be present, and if they are present, then it knows, well, I'm building a package, or I have already downloaded everything, so I can just continue working normally, and I don't need to do the web installer stuff. If those landmarks are missing, it then invokes the logic to download everything. For the detection part, we decided to do that programmatically, so we did not want to do that in a declarative mode, because the other systems like eggs or wheels, they try to put all of this information into the file name of the distribution package. and then try to make the installer smart enough to detect that this particular file is compatible with the platform I'm currently running on. And that kind of does not really work out. And that's also one of the reasons why these installers often don't work on all platforms. What we're doing is we're actually running code on the installation platform, and the code can be made smart enough to actually detect the platform specifically for the package needs. So we can add extra checks like CPU checks, or we can add checks for certain libraries being installed, or then maybe if the libraries are not installed, warn the user about the fact that these libraries are not installed, and maybe tell the user how to fix this. And to encode this information, we use tags. So it's a very simple kind of way of I don't know, writing down everything that you found on the platform. And in order to find the right package to download, we use those tags and then match them to information that we have for the packages that we host on the server to download the right package. And we use a matching algorithm for that, which is actually very simple. So it's no rocket science there. Right, and our solution, of course, was to just use what we already had. We had this mx setup.py distutils extension. We've been using that since 2001, so quite a long time. There's lots of stuff in there. So, for example, it supports uninstall. We have something called pre-built packages, which I'm going to get to in another slide. We added the web installers to that. It supports Python 2. It doesn't support Python 3 yet, but we're working on it. Right, what is a pre-built package? So, because we found that many of these binary formats that were out there didn't really work for us, we decided to do something different. And what we did is we ran distutils to build the package, and right after building it, we saved the state of distutils at that point and put the state into a pickle. And we added the pickle to the package file together with all the build files. We left out all the source files because we don't need them, and we wrap everything up in the zip file. And then we ship the zip file to the user, and on the user system, we basically let distutils continue right at that point where just build the package, and then let it continue to install the package in the usual way. So the interface is basically the same as you would run a setup.py install. To distribute the web installers themselves, we added a new command, this sdisweb, and that basically is more or less exactly the same as the source packages that you can create with distutils. It takes care of some other things, like, for example, just including the top-level.py files, just the important stuff. It also has it includes something called setup.tags, which includes all the tag information. And the packages that it creates, they feel like source code packages. So all the installers will recognize those packages as source code packages. Right, tagging. This is the way that we identify the platforms. So we define a few of these tags. And for each of the distribution files that we put up on the server, we define a set of these tags so that the installers can then look at at that information, and then determine whether that particular file fits to the installation platform. So, for example, here we have a pre-built format. It's runs on Linux. It's a 32-bit one. It's meant for Python 2.7, and it's UCS 2 for Unicode. And then we put all that information into a file, the setup.tags file, associated with the URL. So for each URL that you have, you get a set of tags, and then the matching algorithm can then take care of choosing the right one. And it's a very effective way of making sure that you get secure downloads, you get authenticated downloads, because you don't even need HTTPS anymore, because you can check the checksums in your package, and you know that you've uploaded everything to PyPI, and on PyPI everything is hosted using HTTPS, so you get the complete chain of security for your web installers. And you can host the files themselves on arbitrary platforms. They don't have to have HTTPS support at all. They don't have to be hosted on PyPy. You can use any other system that you like. And it's still secure. So this is how one of these files looks. It's a bit small, so I'm going to just grab a few entries in there. So you can see here, there's still some platform information in there, which is basically a leftover of these pre-built files that we, this pre-built format that we used before we had these web installers. And then it just has this error here, and then just gives some tags. So it's a really easy to parse format. You just do a split on the error, and then you're done. This is a more complete example. Again, it's very small, so I'm just going to grab this is the one with the URLs down here. I'm going to make that a little bigger. So again, you start with the URL for the package itself, and then you use hashtags to add extra information. So you add an MD5 checksum, an SHA1 checksum, then a 256 one, and you also add the size. So when the web installer downloads that package, you can immediately, for example, look at the size and see that it has downloaded the correct size, so it's more likely the correct package, and then can continue doing these checks on the platform, so it knows it gets to the right package. Right, how do you create these? Well, one way, of course, is using an editor, just putting everything into that file using an editor by hand. Or because we didn't really like that, or we just put some code into this MX setup, which builds all these pre-built packages, and you just make those, the command creating those pre-built packages, write those tags files for you. And this is what we do in our make file down here, so it's all automatic. We don't have to do that. And then in the setup.py of our packages, we just have to run the web installer. And as you can see, you pass in the landmarks down here, you pass in the path to the installation directory. So this will run on the installation platform, and it will run, for example, under control of pip. And pip will typically put something into the temp directory and then generate a random directory name for installing the package. And this is how you get at that package, because you need to download extra stuff into that directory. Right, and this basically does all the magic. The way that it works is very simple. It checks for the landmarks. If they're present, then it knows it doesn't have to do anything, so it just continues normally. If the landmarks are not there, it knows it has to download something. So it looks at the setup tags file. It determines the platform tags by running some checks on the platform itself. It uses a matching algorithm to find the right URL. Downloads everything, does the checksum checks, and then unpacks everything into the installation directory, and then we added another double check for the landmarks to make sure that it actually downloaded something that makes sense, and adds the landmarks, and then continues with the installation. So what's the current status? We have mostly everything done. We haven't done the HTTPS certificate checks yet. We're still working on that, and we still need to write the documentation. Availability, this whole thing is open source. It's included, this MX setup, it's included in the MX base package. We actually ship MX base with this web installer. We also ship the MX ODBC with it. And so far we have had 0 complaints about this, so it seems to work quite nicely. And of course, roadmap is we're going to add documentation to it, and maybe also add some extra checks to it, like signatures, for example, and also maybe support additional binary formats apart from this pre-built one that we currently have. Right, questions? Yeah, Larry?
Why do you have 3 different checksums on the URL?
Just because we could. You don't really need it.
No, you don't.
This was just because we can. Yeah, it was.
Do you verify all of them?
Actually, yes, we do. It's a bit slow going backwards. I don't know why. There you go. Yeah. Of course, I mean, if if you want to be secure, you really don't need this one, right?
Yeah.
But for example, there might be some platforms where you don't have this. I don't know which Python version introduced the SSH256. I think this one is supported on all Python platforms. This one was added to the 3 maybe. So it's rather old, so this is pretty much available on all platforms. This was added later on. And of course we could put the GPG signature in here as well, or at least a fingerprint or something, to make it even more secure. And what's nice is you can just put your files anywhere you want. You can put it on GitHub, for example, or I don't know, some CDN that you like, or your internal service in the company. So you don't rely on this on the public resources necessarily. Yeah. Other questions? Yeah.
This relies still on Python being already installed on the machine, though, right?
Yeah. Well, you're installing Python packages, so it's kind of. Yeah. But
Yeah.
for that, we have a different solution.
Yeah, I was saying, are there any plans to go more in the direction of Py2x getting down?
No, we have something called eGenix.com, which is it's a complete Python Python runtime in just about 4 megabytes. It's just a single file on Linux. So that's a separate talk. Other questions? No? It's been a long day, yeah. All right, thank you.